Next, we have Doug Koonz with Johnson Controls doing CCT tips and tricks, best practices. Come on up, Doug.
My name is Doug Koonz. I'm with JCI. Tenured veteran. I've been with JCI since September. So I've been there for, 8 months now. I say that, but I was an ASI for 10 years prior to that, working on Johnson Controls products. So out in the field, wiring up, sitting on buckets and boiler rooms for years, same way as you guys were. So hopefully I can share some of my knowledge, make things a little bit easier for everybody out in the field using our tools. So anybody who's familiar with Johnson Controls, you'll be using CCT. I don't have slides. It's going to be live presentation because I like to live dangerously. So anyway, figured I'd start with some tips and tricks for CCT. Let's start, I'll spin up a new program. Let's say we're doing a VAV program. We'll call this pre-con. So anyone who's familiar with our tools knows that we have a selection tree. So you can spin up a program pretty easily. Depending on what you chose, if you're doing a VAV, for example, you'll have different selections that come up. If you're doing hot water, incremental output, proportional output, right? Most of us, we're using 0 to 10 volt actuators. So go through, select the tree, hit finish. We'll give it just a second, it'll spit out a VAV program. And once it does that, I'll show you a few things you can do if you're using our standard applications, as we would call it. So here's a standard app, right? This is what it would spit out as a VAV controller. Now every time I spin up that VAV controller, I've got to go through my selection tree and I've got to say, okay, I'm doing a proportional valve, or it's two-stage electric heating, whatever it may be. One of the things you can do with CCT, if you weren't aware, you can predefine what your defaults are. So in our settings, system selection, here's all the different systems that you can select as you're doing a standard application. So let's say for VAV, for example, if I select this one, if I'm not doing floating actuators, if I'm doing 0 to 10 volt actuators, 2 to 10 volt, whatever it may be, I can go ahead and down to my coils, select proportional output as my default, right? So now I don't have to make that selection every single time that I'm doing a standard application in CCT. So you can set those for all your different programs. If I save this, when I close, if I go and spin up that VAV program, that single duct application, now I have my predefined, because typically you're working with the same engineers, you've got 80, 90% of the time, you're gonna have the same selections, right? So there's no sense in having to select that each time. So that's kind of a nice little tip and trick for CCT. Again, that was settings, system selection. Another thing you'll notice is once we did that, you can import and export different default settings. So if you've got a new tech coming on, you're a senior tech, you've got this developed based on the engineers you've been working with for years, you can just export that and import those defaults to anyone else. So your newer techs don't have to sit there and set their defaults each time. That's just one of the tricks that I like to use in CCT. Another one, and this is one I think is pretty big, is the naming and signal. You'll notice this default application, it's got dashes in it, right? And everybody knows how well dashes play in the Tritium platform when we bring that in. So if every time I use a standard application, if I've got to spend time going through and changing these dashes to underscores, that's going to be time consuming. What you can do is under settings, naming and signal. Once this pops up, I can go through and set what the predefined suffixes are for all my names. Now, there's about 5,000 different names in here, so you can one at a time click. If my computer wants to play along anyway, there we go, click, replace this with an underscore. Just do that like 5,086 times and you'll be fine, right? So take a week and a half, get your naming taken care of. Or what you can do, I can go to naming and signal. Once this pops up, I can export this whole table. I'll throw it just on my desktop for now. We'll call it object naming properties. That's what it is. Now take a look at this. Whatever all this is, don't worry about that. like I said, I like to do live demos and live dangerously. I can take this object naming that I just exported, change this to a .csv. Yep, sure I want to change it. Let's open it up in a spreadsheet, and we'll take advantage of Excel's properties. Has anybody used this object naming, changing the default names at all? Or is this new? You've used it a little bit? Okay. So once this is open, I'll just do a find and replace. I'm going to say replace all the dashes with underscores, replace all. 5,127 replacements are made. So now I hit OK. So that beats the hell out of doing it for, I don't know, 2 weeks straight, just plugging them one at a time, right? So I can save this, close the file. Then all I have to do is change this back to a .properties, which is what CCT is looking for. Make sure I spelled that right. Looks like it. So then I can go back to my naming and signal here, and I'll be able to import that .properties. I'm not going to do that right now because, as you saw, there's 5,127 different properties. Oh, I think I clicked. Oh, there we go, import. I might have spelled it wrong, but either way, when you go back to .properties, you can import it. It takes about 5-6 minutes to run that import, but now all your default point names will be underscores instead of dashes, right? So a couple different examples. I've seen some government jobs I've been on where they've got very specific naming conventions that are kind of outside of what JCIs are. So it's really nice if you have different files that you can import different naming conventions for different engineers you're working with or different college campuses, whatever it may be. So that's kind of a nice little trick. So the other piece with the predefined applications, the standard apps we're using, like I said, you can set what the default selections are for the standard apps. But over in define hardware, you can also set what the default controller is, right? If you're a typically Ethernet-based company, or you're typically MSTP, whatever it may be, up in define hardware, there's this default controller tab. And you'll see there's the different system types here: air handling units, central cooling plants, custom apps, et cetera. So here I can take this air handling unit and say, okay, whenever I do an air handling unit, I'm using a CGM 4060. Probably not the case, but it's the first controller I saw there, right? So you can, instead of having to define the controller each time, now you just spin up air handler, it has your predefined selections, has the predefined controller. Those steps are taken out of the equation for you. Let's see, default controller. I think the other thing I want to talk about as far as tips and tricks in CCT, something that used to drive me nuts as a user, was in the standard applications, these manila pieces of logic, I can right click, I can view logic, see everything that's going on, right? Anybody who's familiar with CCT, you're familiar with that. But these white blocks used to drive me nuts. I don't know, for me as a system integrator, as a programmer, if I don't know everything that that program is doing, I don't trust that program. Well, zone temp set point determination, let's use this one for example. We can probably assume what that's doing. You've got unoccupied, you've got standby, you've got occupied for your set points, right? But if I want to confirm exactly what that's doing, or any of these white blocks where I can't see the logic in the program, if I just go to the details of this block, there's a little help file up here. And if I click that, it'll bring me to the help topic specifically for that function block, and I can see exactly what it's doing, step by step. So while it's not wire sheet logic, you can't see it that way, you can at least get a description of what it's doing, and that helps. So that's about what I've got for quick tips and tricks in CCT. What I want to talk about here is states tables for a little bit. We've got this air handler program I spun up, and down here we have these state tables. What the heck are they, and how do we actually use these? Most of our standard applications, this is kind of a smaller one. You'd see 6, 7, 8, 9 different tables, and it just gets a little bit confusing if you don't actually know how to use them. But if you do, they're clutch. So here's what I'm going to do. I'm going to do a new application. We're going to start it from scratch. We're going to spin up a couple pieces of logic with some side loops, and I'll show you the best way to use these states tables. Call this pre-con, custom application. Spin up a base program. Does anybody take advantage of the states tables? Is anybody confused as to how to use the states tables or what they're doing? There's usually at least a few hands go up there, so. I think starting with a base application and not having all these 20 different states tables helps to clarify things. Oh. I spun up a wrong application. My apologies. Like I said, live demos. Custom application, there we go. This is going to be a blank program. Next, finish. Okay, so in a state table, in a custom application, you'll see there's these two tables that exist. They're stars, they're not connected to anything. We'll get rid of those in a second. So if I bring in a piece of logic that I wrote earlier, when I was sitting in the table back there, really simple, terrible piece of logic, don't judge me on it. And I'm going to build 2 points. This is just for show. We've got an awk point. We've got an outside air temp point. All right, so I've got this logic. It's, if outside air temp's less than 50 and occupancy is true, then enable some heat, right? So what I can do, if I'm enabling heat with a side loop, say I'm controlling discharge air temp, I'm going to create a PID, right? Create a PID. Call this my heating loop, and it builds a couple things for me. It'll build my output, it'll build my process variable, my input, it'll build a couple of points, a tuning reset, because we have an auto-tuning PID loop, our PRAC, pattern recognition, adaptive control, and it creates the PID as well. But one thing it also creates are these states tables. You'll notice on the right side, I've got this heating loop control, and on the left side, think of this as our inputs. So we've got inputs on the left, outputs on the right. Inputs in rows, outputs in columns on the right. So how do we actually take advantage of this? Well, let me make this window larger. I'm going to edit, and I'm going to right-click and delete these two tables that were existing. Notice they're orange. That's because nothing's connected. I'm also going to delete these two columns so that we just have that heating PID loop state table we just created. We'll apply that. Now, if we look at our PID loop itself, you'll notice there are 4 different states. We've got off, max, control, and hold. So what does that mean? Off is 0, max is 100%, control, the PID's actually doing its function, and hold, it's just holding in place. So when we created this PID loop, it created a couple things. The state table, it created our output here, created our input here. It also created a reference back. So that hold position would be, say I override that output, the PID loop needs to know so it doesn't wind up, right? So that's a function that we've got. So how does that all play into the states table? Well, let's take a look there. If we look at the states table, there are 2 states with a side loop that's created. On the left side, we've got our inputs, and on the right side, we have our output for that heating loop, what it's going to do. If I think of that column, if I think of a ball that's falling, just looking for a place to land, that's the easiest way for me to think about that state table. So as this heating loop is looking for something to do, it's looking on the left side saying, okay, the first thing, is this heating loop PID in a tuning reset state? If true, then tell that heating loop to go into hold. We don't want the loop actually winding because we're resetting the tune. If false, don't do anything. There's a star. Look for the next place to land. Right? So now the heating loop is looking, am I overridden? If false, well, then go to control. If I am overridden, then hold, right? Output's overridden, we don't want the PID winding up. So how do we take advantage of that property of the state table? So we brought in this piece of logic earlier, right? That was, if occupancy is true and outside air temp is cold enough, then enable the heating loop. Let's tie that into our state table, that piece of logic. So in my states table, I can edit, I can right click, and I can create a state selection table. Call this heating enable maybe, right? I'm going to tie it to a Boolean point. Table priority, we'll talk about that in a second. Now again, I want this column on the right looking for something to check. The first thing I want to check is maybe, is the heating even enabled? Well, because it's a ball falling from the top, It's looking for the first priority. I wanted that to be heating enable. Oops, I put that at the bottom. No problem, I can use these arrows, just bump it up. So I say, okay, if heating is enabled, false, then shut that PID loop off. If heating is true, is enabled, I could say, go to control here, but then it'll never move past that point to cross-reference if we're in a tuning reset or if we're overridden, right? So if it's true, I'm just gonna say do nothing, look to the next thing. So I apply that. Notice that state table I just created is orange, the other ones are yellow. Well, that's because I need to actually connect my logic to that state table now. In my connections tab, right here, where you're used to seeing as I click on the different pieces of logic, what's connected where, you can also see what's connected into the state table. If I hit that show state selector under the connections tab, I've got that heating enable state that we just created, right? So I'm just gonna right click there and make that connection from that logic. There we go. Now if heating is enabled, that's tied to the heating enable state table, and I could take advantage of that. So what's another way we might be able to utilize that? Well, let's say I had a free stat. Sorry, a low temperature alarm. I'm not allowed to say free stat. So if we had a free stat, what do we want that heating valve to do if a free stat trips? Probably want it to go to max, right? So I can create another state table. Edit, create state selection table. I want this to be the first priority. I'm gonna connect it to a point that's got normal and alarm. For those of you who are familiar with JCI, you'll know that the state's texts have to match in order to link. Call this free stat. Say, hey, if free stat's an alarm, send that PID to max. Slam the valve open. Now you're gonna wire that valve so that it's electrically gonna slam open anyway, but it's nice to see it on the front end as well. I'll go to my connections, show my state selector, make that connection to the free stat, right? So back over to the states table again, the left side is just inputs in rows, and the right side is your outputs. So one last thing I'll show about these states tables. If I created another side loop, maybe this is our economizer damper, right? It's gonna create my output for that PID, it's gonna create my process variable, it's gonna create tuning reset and set point. It'll also create a state table. Now we've got a state table, a second column here, specific to the economizer, right? We've got the heating loop output, we've got the economizer output. Neither of the two of them care what the other one is doing. They only care what's going on the left side. And if any of those conditions are meeting and they have a condition to go to based on what's happening, and there you go. So nice way to take advantage of this is that free stat. If that goes into alarm, I want my heating loop to go to max. I want my economizer damper to go off. And apply it. So, like I said, it's all just a matter of each column has its own ball falling, looking for a place to land. And that's how the states tables work. Using the connections, showing state selectors, you can do the different connections. But I found for years that's a great way to take advantage of the states tables. When you first look at a new program, there's 30 states tables and it's overwhelming if you don't know what you're looking at. But no matter how many states tables you add, we could add another one here, say we've got a modulating fan, right? We've got our fan control, same thing. Free stat trips, I want the valve to go to max, I want the economizer to go off, I want the fan to go off. So, nice way to take advantage of the states tables. Hopefully that clears up a lot of the myth or the mystery about how states tables work for some of you guys. All right, so let's do one more thing here. Let's spin up a new program. I'm gonna do a VAV, single duct, and I wanna talk about the sensors that we have. We've got our NS7000 series, we've got our NS8000. When you go through a standard application, when this spins up a new program, it's gonna have an NS7000 sensor in the program. So how do I convert that? Well, there's a few different ways. One, once this spins up, I can take a look. See, this looks like an NS7000 sensor. I can click here, look at my connections, find my zone set point from the sensor, the zone temp from the sensor, and see all those connections. So I could go to define hardware, I can build a new NS8000, delete that NS7000, make all those connections manually. Wow, that's terrible. Okay, there's a quicker way to do this. What I can do is I can take this file, we'll just save this on the desktop for now. Actually, we'll just save it right there for now. Save as, VAV. Here's where EasyCAF comes into play. EasyCAF is another tool that we have for messing with existing CAF files. If I go for EasyCAF and open this up, there's two things that I think are the most valuable with EasyCAF. One, you can use it to change your BACnet object IDs. Anybody who's used CCT knows once you create a point, the BACnet object ID is static. Well, what if I need to change that? I've got multiple exhaust fans on multiple controllers. I want them all to have the same instance ID, or excuse me, object ID. EasyCAF, you can do that. If I file and I open in EasyCAF that program that we just created, you'll see the same properties of the CAF file that we saw in CCT. I can just view it in EasyCAF now. What I can also do is, under my tools, bear with me, bear with the computer, live demos, here's where it tends to hang up sometimes. If my computer catches up, I can go to my preferences for EasyCAF and change it to advanced preferences. Tools, options, view type would be standard. I'm going to change that to advanced. Now, when that's advanced, I can go to any one of my outputs within this CAF file. And up here, I can change this object identifier from AO 2014 to AO anything else I want it to be, right? 2016. If there was another object that was using that same instance number, you would get an error for it. You'd get at least an alert. It'll still allow you to change it, but then it'll take that object identifier away from the other point. But the other thing that you can do with EasyCAF is I can take this sensor and I can convert it to an NS8000. Just right click on it, convert to NS8000. Make sure you select the latest revision, hit OK. There we go. So that beats creating a new NS8000 and relinking all the points that that standard application had in it before. It'll give you a result, converted NS7 to NS8000. It'll also tell you that it went from an AI 1106 to AV 1002. It's just the way the NS8s work. They're AVs instead of AIs. So that's something to be aware of. If you've got maybe an existing system where you've got a ton of sensors you need to convert, I have a file that I can share with you as far as filling the program services in Tritium and actually making that happen. But then you save that file, now it's converted. So those are a couple quick tricks that you can do with APLT, or excuse me, with EasyCAF. Last thing I'm going to show you is APLT. So once this spins up, this is our batch upload and download tool. Not a lot of people have taken advantage of this. I know I didn't for years as an ASI, and then when I came to JCI, I had to learn about this tool, and man, I wish I knew about it for years prior. We'll see if it wants to open. So again, for anybody who's familiar with CCT, this is when you first open APLT, you'll see, I got click happy, I got a few instances open. There's different connection types. Same way you would connect to any of your controllers in CCT. You have connection types on the left side. For me, I like to tunnel through the JACE. I just find it way easier. So I'll specify my JACE, my network number that I'm connecting to, and then there's the different operations. I can either transfer multiple CAF files to controllers. I can upload multiple CAF files from controllers. I can use online commands to enable logic, disable logic if I want to, and I can read-write attributes online. So let's say I'm uploading multiple controllers. We'll see if we want to connect. I'm going to hit next. It's going to connect to the network. Once it does, I'll discover. And you'll see, I think I've got 2 controllers here. And assuming routing is enabled on my JACE, I should be able to see these controllers. But I also haven't gotten into my JACE to confirm that, so I prefer to do that in front of 100 people to see what happens. And I think I don't have routing enabled. But you would see the controllers, and you would see the destination file column right here. This is where I can go ahead and specify where these controllers are going to upload and save to. I can also, in File, Preferences in APLT, I can specify when I upload folders where those files are going to save to. Right? So this beats uploading one controller at a time in CCT. You can upload an entire trunk at a time. If I go back, same thing. I can do online commands. If I downloaded a controller but I didn't enable the logic, maybe I'm on a job site, I've downloaded 100 controllers, I don't want fans to start, I can go back after and buy an entire trunk, connect, go to online commands, and then enable the logic. Or if I've got a pending file, because you can download files in the background, I could activate that file, right? Another thing that's nice is the transferring caps to multiple controllers. Where CCT, you can open up one CAF file, you can use online operations, you can download to multiple controllers. But what if I have multiple CAF files that I want to multiple controllers? Same thing, I can discover devices, I can specify what resource file, what CAF file I'm downloading controllers and do it here. Or, if I wanted, say I've got VAVs and I want to write different files to them, I can change my basic view to add other files. Say I want to write my area, my K factor, and my flows to controllers at the same time. I could discover a controller and I can propagate it this way, or check this out. I can hit plus, I can add a new row, say this is AHU1, VAV1. It's using this device address, and we'll use this resource file, open, and I'm gonna add a file this way. I can plug in a couple different pieces right here. I can do my area, my K factor, flush positions, cooling max flow, et cetera. What if I've got 50 VAVs on this trunk? Well, I can sit there and do that manually, or I can go ahead and export this column to an Excel file, and just like we did when we were setting our different names in CCT, I can take advantage of the Excel properties. Oh, where did I chuck that? One more time, let's export this. Let's throw this on the desktop. There we go. Export. Now watch what happens. If I open up that row in Excel, I can take advantage of Excel's properties. I had a bunch of views there. I can just drag and drop. Now I've got all these VAVs, right? Couple things that don't work out that way is this device address. You have to go through and drag this column on its own. Same thing with the device ID. I have to do this on its own. But now, when I save this file, if I go back over to APLT, where I exported that file before, now I can import that same file that I've played with in Excel. I've copied all my flows from my submittal documents right into that spreadsheet. I'm going to import it. Now all my VAVs are there with their flows ready to go. I can connect to the network, I can download, I could write all the flow attributes if I want. This is our batch editing tool, and if you're not sure how to use this, this is huge. Maybe at some point we can work with Cochrane and put on maybe an hour-long webinar to go through all the different aspects of APLT. But again, if you're a CCT user, if you're a JCI user, I would highly recommend becoming familiar with APLT because it'll be a huge time saver for you. I have 1:52 left, so here's what I'm gonna do. I'm gonna break out real quick and I wanna show you CWA and our CWCVT. So if you're not familiar with our CWCVT, that's this tool right here. Plug in and download to our controllers. There's an app that we came out with about a year ago for connected workflow applications. You can get it on iPhone, you can get it on Android. Here's what it looks like. There's a few different things you can do with it. Right now, you can use it for commissioning. So if I wanted to download, this is kind of walk through on how to use CWA. We can touch base on this afterwards. Come see me at the booth if you want. But I just want to show you, you can use this for going through and doing your point-to-point checkouts, overriding just like you would from CCT, but on the phone. And the big one we just came out with is we've got it for a balancer app as well now. So you can give CWA and a CWCVT to your balancer, have them go around, and they can just plug into the thermostats and use this CWA for balancer, go through, take their measurements, plug in the K factors, plug in the flows if you want them to do that, or you probably would have already downloaded and put the flows in. But now you don't have to sit there and babysit the balancer, right? We've all done that, spent many, many hours. You can still be on site because there's likely stuff they're gonna run into, but if you can just give them one little piece of hardware and an app and say go, that's a huge time saver for your techs in the field while they're working on building out the front ends, checking out other controllers, right? So I think that's about what I have And hopefully this was helpful. If anybody has any questions, I'll be here till Friday. Come up and see us at the JCI booth, and I'm more than happy to talk APLT, CCT, states tables, anything you need. So thank you very much.